An introduction to calculus, starting with differentiation. Now we're first of all going to look at the gradient of a straight line. We know how to find the gradient of a straight line. We choose 2 points on it. Let's say x1, y1 and x2, y2. We draw a triangle under the line. Now we can see the height is y2 minus y1 and the width is x2 minus x1. So the gradient is the height over the width, which is y2 minus y1 over x2 minus x1. But note, this definition does require 2 points on the line. Now supposing we want to find the gradient of a curve. The problem is that the gradient changes along the curve. So each point has a different gradient to the points around it. So we define the gradient of any point on the curve as the gradient of the tangent at that point. But we only know 1 point then on the tangent. So how can we find the gradient of the tangent? Well, let's start by considering the graph y equals x squared. And suppose we wish to find the gradient of a point P with coordinates 1, 1. Now we need to find the gradient of the tangent at P, but the tangent only goes through one known point. So instead we try to get an approximation of the gradient. And to do this, we choose a point Q on the curve fairly near the point 1, 1. So let's say x equals 2, then y equals 2 squared, which is 4, and so the point Q is 2, 4. Now the gradient of the line PQ is y2 minus y1 over x2 minus x1, which is 4 minus 1 over 2 minus 1, or 3 over 1, which equals 3. Now this line is not the tangent, but it's quite close to the tangent. It would be better if we could choose a point Q closer to P. So let's choose x equals 1.5. In that case, y equals x squared, so y equals 1.5 squared, which is 2.25. So the gradient of PQ is y2 minus y1 over x2 minus x1, which is 2.25 minus 1 over 1.5 minus 1, or 1.25 over 0.5, which is equal to 2.5. Now this line is a better approximation to the tangent, so 2.5 is a better approximation for the gradient. Now let's suppose we take Q closer still. Suppose we take Q at x equals 1.1. Then y is equal to x squared, so y is equal to 1.1 squared, which is 1.21. Now we can find the gradient of PQ. It's y2 minus y1 over x2 minus x1, which is 1.21 minus 1 over 1.1 minus 1, which is equal to 0.21 over 0.1, which is equal to 2.1. Now this is an even better estimate of the tangent's gradient. Well, let's take Q even closer still. Let's take Q with x-coordinate 1.001. Then y is 1.001 squared, which is 1.002001. So the gradient of PQ is 1.002001 minus 1 all over 1.002 minus 1, which is equal to 0.002001 over 0.001, which simplifies to 2.001. Now this would be an even better estimate of the gradient, and it appears that the closer Q gets to P, the closer the estimate gets to 2. So perhaps the gradient of the tangent is 2. Let's look again at the gradient of the curve y equals x squared. Now, to find the gradient of the graph y equals x squared at the general point xy, draw the graph with a point P with coordinates xy on it. Then y is equal to x squared, so the coordinates of P are x squared. Now let Q be a second point on the curve with x coordinate x plus h, where h is not equal to 0. Then y is equal to x plus h all squared, and we can expand that bracket to give y equals x squared plus 2xh plus h squared. So we can mark the point Q, which has coordinates x plus h and x squared plus 2hx plus h squared, on the graph. And we can draw the line PQ. Now the gradient of PQ is y2 minus y1 over x2 minus x1. So the gradient of PQ is x squared plus 2hx plus h squared minus x squared all over x plus h minus x. And we can see that the x squareds disappear on the top and the x's disappear on the bottom. So the gradient of PQ is 2hx plus h squared all over h. And we can divide all the way through on the top by h and on the bottom by h. So we get the gradient of PQ is equal to 2x plus h. Now we want to find the gradient of PQ when Q gets as close as possible to P. As h gets smaller and smaller, then the gradient of PQ gets closer and closer to 2x. It'd be easy if we could assume that h was equal to 0, but the equation above only works if h is not equal to 0. We assumed that back at the beginning. So what we say is the gradient of the tangent is equal to the limit as h tends to 0 of 2x plus h. So we imagine h gets very, very, very small, and that gives us a very, very good approximation to the gradient of the tangent. So we can assume the gradient of the tangent is 2x. Now 2x is called the gradient function of y equals x squared. Newton came up with the gradient function and he called it y dash. So we can say the gradient function y dash is equal to 2x. Let's look at an example. Find the gradient of y equals x squared when 1. X is equal to 0.8, part 2, x is equal to 1.4, and part 3, x is equal to minus 0.5. Well, to solve this, we have y equals x squared, so the gradient function y dash equals 2x. So the gradient is 2 times the x coordinate. So if x is 0.8, the gradient at that point is 2 times 0.8, which is 1.6. In part 2, if x is equal to 1.4, the gradient is equal to 2x, which is 2 times 1.4, or 2.8. And in part 3, if x isn't minus 0.5, then the gradient is 2 times minus 0.5, which is minus 1.